Hello and welcome to another video, this time for EDEXCEL A-level maths. This is year 2 topic, function mapping and graphs. So I want to spend very few minutes or seconds to define what mapping is. Mapping, as you understand the word map, it maps something onto the other. It transforms a set of generally the numbers into another set of numbers again. Okay, we have seen mappings in junior school. We used to call it function machine, if you remember, in your primary school or year 7 in year 8. And the two keywords which get associated with function machines were input and output. Okay, input is the numbers which can go into function machine. That is the first set of numbers, and output is numbers which come out of the first function machine after something's happened to them. That is the second set of numbers. Okay, second set of numbers, right? And all mappings are not functions. Mappings are of a couple of types. I'm going to write down one-to-one mapping, many-to-one mapping, and one-to-many mapping. I'll explain to you what does it actually mean, then we'll see which of these mappings can be classified as functions. Okay, we have some transformations from one set of numbers to the others. If I have this and this, what does that tell me? Every element or number of the input set is going to one different output number of the output set. This is one-to-one. Many-to-one, when two or more inputs can give you same output, that's many-to-one. And one-many is when one output can give you one input can give you two outputs. One-many mapping. Okay, obviously you can join this with this as well, that doesn't matter. So three types of mappings, and some of them are functions. We're going to talk about functions in a minute. Okay, I can give you algebraic examples of these as well as we go through the video. So the definition of function is which mappings are functions, which if every input has a distinct output. So in this case, this input has distinct outputs. Yes, this can be a function. This input has a distinct output. This input has a distinct output. Distinct means that one input doesn't have more than one output. Okay, distinct means different. So this can be a function as well. For here, this input doesn't have one and only one output. It's got two. So it's not distinct. This cannot be functions. So mappings which are one-one and many-one can be functions. I'm going to give you an example when this case probably doesn't work. Let's have a look. Here is another representation of mapping. We can see this has a distinct output. This input has distinct output, but this mapping is not a function because every input does not have an output. So this is not a function. Right, so we're going to give you algebraic examples for this now. So for a one-one function, if we just write y equals 2x plus 5, any straight line, if you want to draw the graph for this, you're going to get something like this. For every input or every value of x there, we'll have one and only one value of y. So this is a one-to-one function. For a many-one function, y equals x squared plus 3. Okay, so for certain values of x, for two values of x, one on here, we can give you the same value of y. This is a many-to-one function when two values can give you the same value of the output. All right, so we move on now. What do? We're going to give you a couple more instructions here, guys. The input set which a mapping or a function is defined on is called domain, and the output set, remember output set, all the outputs which are possible for all the inputs of the function is called range. These are two very important names. You need to memorize this, you need to learn them, and we'll carry on from here. How do we find domain and range, and the graphing of the function will be very important. Before that, I'm going to introduce to you another very, very important word. It's called modulus function. And actually your book deals with this first, and then it moves on to mappings and functions. But that I thought this is better order. You should know what function is before we introduce modulus functions. Okay, really important that you understand this very well. This is the notation, and it's called, in short, it's called ModX. Guys, where have you seen this in your first year's maths? Is in mechanics, in vectors a little bit, and it's called magnitude. In vectors. Okay, modulus is also represented by a thing called difference. Okay, I'm going to ask you a question. If temperature of a day rises from 5 degrees to 9 degrees on a winter's day, okay, another day temperature drops from 11 degrees to 7 degrees. In both the cases, if you ask you find difference of the temperature, it would be 11 take away 7 or 9 take away 5. But you can say it could be 7 take away 11 and 5 take away 9 as well. But the answer for difference will be given as, we won't say difference is -4, we say difference is 4, and that difference is represented by modulus. I mean, I don't know if it's a very good example to explain, but what does modulus actually means then? That the answer of the modulus cannot be negative. It is always positive. That's what you associate with the word magnitude. Magnitude is always a positive thing. Right, so modulus of 3 take away 8, which will be modulus of -5, and the answer will be 5, because the difference between 3 and 8 is 5. We're not saying 3 take away 8. Here we say the difference of this. Right. Now we're going to be learning how do we plot the graphs of modulus functions and solve some equations and inequalities, and that will be your exercise first exercise from the book, which is 2a. Alright guys, the first easy question is like this. When they give you a function, by the way, this is notation of the function, most commonly used notation. We say when x is the input in a mapping or in a function, this will give you the output of that x. Okay, so if I have to find f10, 10 is the input, what do? I substitute 10 as x, 4 times 10 plus 3. Using my modulus, this will be 6 minus 40 plus 3, and that's where the modulus function come in. 6 minus 40 should be -34, but because it's modulus, it should be 34 plus 3. The answer is 37. So that is your first type of question, modulus functions. Just evaluate some outputs with the given input. Right, what I'm going to do now, I'm going to ask you, or teach you rather, how do we plot the graphs of these two functions, y equals modulus of 3x minus 5, or often function notation as well, fx equals modulus of 3x minus 5, and number 2, fy equals modulus of x squared minus 5. Now, what my advice to you people here is that you draw a graph first without the modulus at all. Okay, then we take it from there. I'll pause the video for a minute. I would like you to draw the graphs of these two functions, considering there were no modulus given to you at all. Then we take it from there. All right, here we are then. This is the first graph of y equals 3x minus 5, positive gradient of 3, y-intercept is -5. Okay, this is the graph of y equals 3x minus 5. What we need to plot is graph of y equals modulus of 3x minus 5. What does that tell me, people? The definition of modulus tell me whatever comes out of this modulus, this box, cannot be negative. That means y can't be negative, so y has to be greater than 0. Let's identify, do we have y less than 0 in this graph? Yes, we do, over here. Okay, anything after that graph is y is negative from this portion, so this can't happen. So what do we do then, people? We reflect this portion of the graph in the x-axis because we want y to be bigger than that. So that is the graph for this function, and this point the y-intercept would be positive 5. Okay, so guys, this v is the graph of that function, and original graph helped me to figure that out. And you can actually in exam show it like this as well, then obviously write it like this, that this is the graph of y equals 3x minus 5. Okay, or it's better to do it twice, just do it once in rough, then draw this again. Alright guys, can you similarly do the second one then, y equals x squared minus 5, and we'll go over that in a minute. Okay, then here you are. This is the graph of y equals x squared minus 5. It's just the x squared graph transformed 5 units down. Now what we need to do now is, people, we need to figure it out. A graph for y equals modulus of x squared minus 5. Same definition. Y is the output of something coming out of this modulus, and that cannot be negative. That means this portion of the graph, which is below the x-axis, need to be reflected above the x-axis. So I'm going to cross that out, and this is not the graph I'm going to be needing. This goes up to 5, and that shape actually is the graph of y equals x squared minus 5. And I want to explain one more thing into this, guys. This red line here is y equals 3x minus 5, and this line actually becomes y equals negative of 3x minus 5. Okay, because positive 3x minus 5 would have gone there. We've reflected it, that becomes y equals negative of 3x minus 5. And you know this reflection from your previous chapters in the first year. So when you put a minus in front of it, y equals fx and y equals minus of fx, guys, what happens? The graph gets reflected on the x-axis. That's what we try to do there. Alright, so this is question number 11 of exercise 2a. The question actually is this, but I've just split into two parts. Solve this equation which has involving a modulus function, then solve the inequality involving a modulus function. Step 1 is, people, what I'm advising you to do, you're going to draw on the same axis a graph for y equals this and a graph for y equals this on the same axis. This is one of the methods of solving equations and inequalities. The other method is algebraic. We do this first, then I'm going to teach you the algebraic method as well. So I'm going to pause it and you draw the graph yourself, please, and check my answer. So helping in the process, this dotted line is the graph of y equals 3x minus 4, the inside bit. Now I'm going to do the modulus of that. That means I need to reflect this graph wherever it starts going below the x-axis. I'm going to reflect it up. We've reflected this portion above up here. So this v now becomes the graph of modulus of y equals 3x minus 4. But we need something more. We need negative of that. This is same as which I spoke before, y equals fx and y equals of negative of fx. You learned this in first year math. See what's going to happen. Okay, so this red graph now, the red v is the actual graph which you want. This is for y equals negative of 3x minus 4, and this question actually is a variation of the question number 11. I didn't do the same question because I'm going to leave that to you, to yourself. Now guys, we're going to be doing what? We're going to be drawing on the same grid the graph of y equals 2x minus 9, which should be a straightforward graph. Okay, that should be a graph on straight line. Let's draw that now. Okay, so the sketch of the graph is this blue line which I've drawn there, and you can see this blue line meets the red v in 2 points there. So these should be the two answers of this equation, and if you're plotting the graphs properly, then you can read the answers. If you're not, if you're just sketching it, then we're going to be using algebraic method to work that out. Okay, so I will teach you how do we find these 2 points now. One of the important points you need to understand in modulus is that the 2 parts of the graph, one of them is y equals the positive answer of that, but obviously this has got a negative sign in front of it, it will be y equals this, and the other part, which is reflected one, is y equals negative of this. So this becomes y equals actually 3x minus 4, you can see that, and this is y equals minus 3x minus 4. And what I have to do, I have to find the point of intersection of these 2 straight lines with this y equals 2x minus 9, and I will solve these 2 equations simultaneously, algebraically or calculator, and work out the answers. Right, so solving equations, equating the 2 y values, that gives you x equals minus 5 on this side, that means this is minus 5, and x equals 13 over 5 on this side, so that means this is 13 over 5, the 2 answers for this modulus equation. And we can see from the graph it's got 2 answers. That's why sketching the graph is really important. Now what we're going to do, guys, we're going to be using this graph and these 2 critical values again to work out the values of these inequalities. Okay, look carefully. Now what do I want? I want my red v, which is of that kind in the graph, below this line, which is 2x minus 9. Now look, these are the critical values, they meet at these 2 points. I want the reds to be less, so I want portion on this side because red will be below, and then I want portion on this side because red will be below. I hope you can see that, guys. As you go, x is less than negative 5, the red line is going to get below this. So the 2 answers, x is less than negative 5, that is this portion, or x is greater than 13 over 5, which is that portion. So that is solving inequalities and equations using mod, and we're going to stop the video here because it's getting too long. Then I'll come back in the next video to do domain and range of the mappings and functions. So guys, I hope you find this helpful, and I'll come back to you with another video. Bye bye.